Well, we're back. Let's see how it fits. Okay, here's number 4. These new fine threaded bolts will need to be torqued so that the adapter plate remains in place under all road conditions. Number 5 and number 6. On this particular engine, we have a solenoid which will have to connect up to power in order to allow the fuel to flow. After the bolts on the adapter plate have been torqued, I put the starter ring gear in place and bolted it to the crankshaft with new bolts. Here the flywheel clutch assembly is placed on the transmission input shaft. This will be bolted to the ring gear after the engine is in by using an access hole that was milled into the adapter plate. It's a lot more room to work with this engine because it's much smaller. Once I'm close, I'll get some bolts ready. I've got the engine in, the transmission in, I've got the alternator in, a makeshift exhaust for now, the starter is in there, battery, all electrical connections are in there, the radiator hoses, the heater core hoses, all are connected, and at this point I'm filling up the radiator. I will also need to add pure radiator fluid to the radiator overflow container. Okay, time to start the engine. But first let me show you how the glow plugs work, and let me show you the motor activation panel I put in the car. Here you see 3 LEDs for visual aid. A push button to initiate the glow plugs, and a switch for the motor controller, which I have installed. There was only a rear defroster switch and indicator on the right. Push the button. When the light goes off, after 20 seconds, we can start the car. If you start the plugs when you get in, by the time you get set to start the car, the LED will be off. Here we go. Yes! Sounds great. After the engine is started and while it is running, I will add water to top off the radiator so that the engine will not overheat. I want the engine to reach its operating temperature. I will be looking for any leaks from the engine, whether it is oil, water, fuel, or exhaust, and repair them if there are any. Welcome back to our second weekend into the hybrid build. The engine ran great, and now it is time to finish the electric assist this weekend. Let me start by going through some of the electrical components and what their purpose will be. I have 3 examples here of what to consider. I have one here rated at 10 horsepower. This is 10 continuous horsepower, which given the correct amount of voltage and current will allow for about 40 to 50 peak horsepower. That is what I can expect for about a minute or so. The second one I have is rated at 4 horsepower, but can get up to 28 horsepower peak. And then I also have this one. This last one is the one I will be using. It has a peak horsepower rating around 20 horsepower and has a nice slim design. The size can be attributed to the fact that it is a PM motor, or permanent magnet motor, and does not need the extra space for creating an electromagnet with batteries. The next major component is the controller. When the controller gets the message to go, it will send a pulse width modulated voltage to the motor and control its rotational torque and RPM. This controller is a 300 amp max output, so the maximum horsepower I can get from the motor under ideal condition is around 20 horsepower. This one is rated at 400 amps. I will be using this one because it matches that of the motor I have chosen. Here's the battery that I chose. These have a high current rating. They are deep cycle batteries and are the best that I can afford for the application. These batteries can be mounted in any position because they contain a gel rather than a liquid electrolyte. They are 12 volt DC batteries, and I will be using 4 of them that will be connected in series for a total of 48 volts. The last components are for safety. Here's a main contactor for supplying the main voltage to the controller. It is rated at 400 amps. The main breaker is also rated at 400 amps and is another safety for the circuit. Here is a fuse that I will be using. The fuse will be placed in line so that if the current rises too high too fast, it will protect the rest of the circuit. This is the potentiometer that will be used for acceleration. On the potentiometer assemble is also another safety circuit. It is a small micro switch. This sends a signal to the controller to ensure that the accelerator is not applied when you turn on the main power. This is to protect you and others from sudden, unexpected vehicle movement should the accelerator be applied by mistake. I will be using 2-gauge wire for the main power. The current will be able to get to where it needs to go fast and not create wasted heat in the wires, but mainly for safety. If a too small of wire is used, they will melt or burn and cause a possible fire. I will be using a plastic conduit to protect the wires. Since the batteries will be placed in the trunk, wires go from the trunk to the engine compartment. I will be using gauges to monitor all of this equipment. I will have a battery level indicator. This shows the general amount of energy left in the batteries. The voltage indicator shows what the level of the voltage, and in this case, should be kept as close to 48 as possible.